Hey guys, hello everyone and welcome to the channel. So today in this particular video I'm going to take 10 tricky questions from quantum chemistry. Now many of you were asking me to make 10 tricky questions on this topic, and it's a very important topic, as you know. Okay, every year you will at least get 5 to 6 questions from quantum chemistry in your CSIR NET exams. So let's take some of the questions and let's try to see them, that how you are going to solve. Now before going into this video, I would like to inform you regarding the upcoming batch for the CSIR NET exam on the Unacademy platform. So I'm going to take live classes for upcoming CSIR NET batch. The classes are going to start from 30th of November. So if you are interested in that, you can contact me regarding how to take subscription and other things, right? So having said that, let's continue with our video. Alright guys, let's take this first question over here, which is asked in CSIR December 2019. Now I have given two questions on the slide because the similar kind of question was asked in CSIR June 2019. So you can see both the questions are based upon same concept, and I'll solve this particular one, and I would like you to solve question number question for the June 2019. Although the answers are highlighted, so you can just match up the answer, that whether you have done the correct one or not. But yeah, you should know the way how to solve it. Okay, the question is regarding the hydrogen atom orbitals, and it says that the wave function is given to you and which orbital does it represents to. So it's pretty simple to solve it. Okay, what you have to see is you have to look for certain patterns. Okay, first of all, in the wave function you have three parts. Okay, you have three parts. One is your part which contains r as a function, like the function which is like it is a function of radius. Then the other one is theta, okay, the function of angle, and then one more angle is there, that is phi. Okay, so like you will get three functions over here, although the function or the wave function which is mentioned to you is only a function of r and theta. It's not of the phi, so phi is not mentioned. So I would tell you that how you can approach. Okay, so first of all, what you have to look for is e to the power minus r upon n a naught. Okay, this is a simple thing which you have to look for. So e to the power, exponential part you have to take, where in the numerator it should have r and in the denominator you should have a naught. So whatever the coefficient of this a naught is, right, that will give you the value of n. So if you compare it over here, you have this particular part here, right? So you have e to the power minus r upon 3 a naught. So what will be the value of n over here? So you just have calculated, or you just have got the value of n is equals to 3. Okay, it's pretty simple, right? We have not done any mathematical calculation, nothing, just by comparing we have just got it. The second thing is to find out the value of L. So to find out the value of L, what you have to look for is maximum, okay, max power, or you can say max order of cos theta. Okay, so you have to look for that in the cos theta, what is the maximum power you have. So if you see over here, the cos theta has maximum power of 2. So that means what will be the value of L? L will be equal to 2. So you just have got n is equals to 3 and L is equals to 2. Now you know that L, if it is 0, if it is 1, 2, 3, what are the letters with which we denote it? So this is denoted by S, this is by P, this is by D, this is by F. So basically, since we have L is equals to 2, so it will be D. Okay, so which wave or which orbital it will represent with, so that is going to represent, so 3 and D. So it is going to represent 3D orbital, and that's how you got your answer. In the other question also you can just relate it like that. Okay, you just have to look for the exponential part and the denominator of that. Okay, if let's say you don't have a naught, if you don't have a naught, just like you don't have an a naught over here, so whatever the denominator is, that is going to be the value of n, the denominator of r by something. Okay, r by n, so that is going to be the value of n over here. So n will be 3, maximum power of cos theta is 2, so L will be 2. And what about m? So you have one more part which is given as e to the power minus I m phi. Okay, it's a function of phi, and you should have m over there. So you get value of m over here, right? They have asked n, L and m, right? So the value of m will be calculated like this, but since it is not there, so it will be 0. So that's how option number 3 is the correct one. So it's pretty simple. Okay, just by looking onto these things, you can find out value of n, L and m. And from previous few years, if you see, these types of question has been repeatedly asked in CSIR NET exam. So it's very important to know how to solve this type of question. All right, now let's look for the next question then. Alright, let's take this next question and let's try to see this. Okay, this was asked in CSIR December 2019 and this was a 4-marker question. Alright, the question says that the spatial part of the dominant resonance structure of lithium hydride molecule is, okay, only valence part of the wave function is shown, so they have just said it like that. You have to tell the spatial part. So where does your where does your electron lies? That's what your spatial part tells you. So there are two parts of a wave function. One is your spatial part, okay, and the other one is your called as spin part. So a spatial part tells you about that where your electrons are, in which orbital it is, and spin part tells you that what is the spin of that. Alpha and beta is how we represent the positive half and negative half spin. So that's how we use them, or that's how we solve it. So now let's look upon that how we are going to do. So we are given with lithium hydride molecule. If you look upon the electronegativity, you will see that hydride is more electronegative as compared to lithium. Okay, so that means you have more electronegativity in the hydrogen side. So if you have lithium hydride bond, okay, so these two electrons, the two electrons which will come to form this covalent bond, so those two electrons will not stay at the center of this bond. Okay, why? Because the electronegativity difference is there. So due to the dipole moment, these electrons will be quite shifted towards hydrogen side. Understand? Both, like the bond between lithium and hydrogen is it is going to form a covalent bond, but due to the high electronegativity of hydrogen compared to lithium, not high but yeah, more electronegativity of hydrogen compared to lithium, electrons will shift towards, or electrons will move towards more electronegative part, that is hydrogen. Now because of that, both of these electrons are going to stay in the s orbital of hydrogen. Okay, so they are not going to stay in the orbital of lithium, they are going to stay in the orbital of hydrogen. So that's why in the options you can see the first option says that 2s-Li-R1, that means the first electron stays in the 2s orbital of lithium, and second, this R2 denotes the second electron. Second electron also stays in the 2s orbital of lithium. This would have been correct if lithium would have more electronegativity. So if lithium would have been more electronegative atom, so in that case electrons would have went towards lithium, and that's why this would have been the correct one. The second one shows the bonding molecular orbital between lithium and hydrogen, in which it is a purely covalent bond. Okay, this type of option will be correct if you have homoatomic homodiatomic molecule, both the atoms are of same type. In that case you will get something like this, okay, where it is going to have plus and minus. So this is bonding and this is anti-bonding. The fourth option, if you see, it shows that R1, that means first electron stays in the s orbital of hydrogen, and second also stays in the s orbital of hydrogen. So yes, this is correct. Why it is correct? Because of more electronegativity of hydrogen as compared to lithium. It is as simple as that. Okay, so but just by applying this logic, you can simply answer this. This question is from the quantum mechanics, but this is from chemical bonding part of quantum mechanics. All right, so let's see the next question then. Alright, the next question over here says that in the linear variation method using two orthogonal basis functions, the two roots obtained are E naught, epsilon naught and epsilon 1, where epsilon naught is smaller than epsilon 1. The correct relation of these with exact ground state and the first excited state energy. So this is ground state and this is first excited state energy. Now this particular question is from the variational principle. If you don't know about variational principle and if you have not studied this topic yet, I would recommend you to watch my video on variational principle. Here I'll just put that link in the I button. You can just click over there and watch that video. It will clear all your doubts and all the things regarding your variational principle, right? So basically in the variational principle we have we generally take a trial wave function. Okay, we take trial wave function, and this particular trial wave function has an energy called as E trial or trial energy. This energy is always greater than or equal to the exact energy. Okay, this thing you should know, and this I have already covered in my videos. Okay, so by applying the similar logic, you can say that this is a trial wave function. This is the energy according, this is the trial energy of the ground state, and this is the trial energy for the excited state. Okay, so what is this? Epsilon naught is what? This is the trial, or you can say energy. I would just write it down like this: energy corresponding to trial wave function, okay, for ground state. All right, And in the same way, epsilon 1 is what? This is going to be the energy corresponding to the trial wave function for excited state or for the first excited state. Okay. Now what are the other terms? So what is E0 or E0? It is exact ground state energy. Okay. This is exact ground state energy. And what is E1? This is exact first excited state energy. Okay, first excited state energy. Now once you know all these things, you can like obviously say that this ground state trial energy is going to be greater than or equal to the ground state exact energy. So what relation did I got? I got epsilon naught will be greater than or equal to E naught, and the other relationship between epsilon 1 and E1 will be that epsilon 1 will be greater than or equal to E1. This is as simple as that for the according to the your variational principle. All right. So answer is your option number 4. See how simple is it, and you just simply got 4 marks due to like for this particular question. Alright guys, let's take the next one then. Alright guys, let's look upon this particular question. There are two questions again. One which is asked in CSIR December 2019, the other one which was asked in CSIR June 2019. Both of them were 4 marker questions and both of them were asked from the same concept, that is Huckel molecular orbital diagram or Huckel molecular orbital. So basically the question, I'll do one of them, the other one you have to do. Okay. It says that the Huckel molecular orbital of benzene that is degenerate with the molecular orbital. The molecular orbital is given to you. You have to see that the one which is degenerate with that. Degenerate means both of them will have same energy. So the concept of energy and degeneracy is that, means the concept of energy is that in the wave in the wave function or in the molecular orbital, how you find out energy? So basically energy depends upon the number of nodes. Okay, it depends upon number of nodes. So if you have same number of nodes, in that case you will have same amount of energy. Okay, it's as simple as that. So if you go over here, if you look upon this wave function, you can see that how many times the sign has been changed. Now see here, this chi2, chi3, chi5 and chi6 are there. There is chi1 missing and chi4 missing. So basically how that wave function would have been, there would have been chi1, chi2, okay, plus chi2 plus chi3 minus chi4, okay, and then minus chi5 and then minus chi6. Now why these two are missing? Why this chi1 and chi4 are missing? It's because the node is lying over there. Okay, the node is lying over there. I would tell, like I will just like to explain you based on the basis of 3 electron system, 3 atom system. In that, if you look upon the wave function, this is how it looks like. Okay, so there are 3 wave functions which we draw. This is the ground state. Okay, the ground state will have 0 nodes, so that means all of the parts will be shaded. The first state, this is like psi1, the psi2 is going to have 1 node, and that node is going to lie on the central lobe. Okay, and because of that, that node is missing here. You just get a point over here. Okay, and here this is psi3, so you will have 2 nodes in this. Okay, 2 nodes. The nodes are here. Okay, like this. So you know that how to find out nodes. A wave function, if a molecular orbital wave function is given by psi n, the number of nodes is n minus 1. So psi3 will have 2 nodes, psi2 will have 1 node over here, psi1 will have 0 nodes. So you have to now see that the given wave function has how many nodes. So see, the sign is not changed up till here, but you got 1 node here, right? First node here. The sign has not changed, it is same only. The other node will be here because your sign has changed, right? So this is the second node which we have. So 2 nodes are over here. Okay, see, if this is a positive side, this is the negative side of that. So the sign has changed because of the missing node or missing orbital. So in the same way, if this is a missing orbital, the sign has changed on the other sides of this. So how many nodes did you got? You got 2 nodes in the wave function, 1 here and 1 here. So 2 nodes here. Now you have to look in the options that where you have 2 nodes. If you look for the first option only, you will see that the sign has changed once here, okay, and the sign has changed second time here. So that's, and no wave function is missing. So that means the 2 times our sign has changed. So nodes are 2 here. Okay, so how many nodes I have? I have 2 nodes in the first option. So that should be the correct option. Let's look for the other ones. Let's see the easy one, the option number 3. How many times the sign has changed? So once that sign has changed here, second time the sign has changed here, and then from plus to minus again we have changed the sign, right? So 3 times we have changed the sign. So nodes are here. How many nodes are here? I got 3 nodes in this. In the last one, sign has changed from plus to minus. So one node, from minus to plus again one node, from plus to minus 3 nodes, then from minus to plus 4 nodes, and then again from plus to minus. So you got 1 2 3 4 5 nodes. So here nodes are 5. This is it is again not the correct answer. So if you look option number 2, you can write it down like this: chi1 plus chi2 minus chi3 plus chi4, and then again you have plus chi5, and then you have minus chi6. Now see how many times the nodes you are getting. So this is missing and this is missing. Fine. So but the sign has changed here once, right? See, from plus to minus the sign has changed. So one node you got here, the second node is here. Then again you can see it's from minus to plus. So again one node is here. So that is because of this missing one. So third node, and then again from minus to plus the sign has again changed. So 4 nodes. So you got 4 nodes in option number 2. Again, that is not the correct one. The only option which has 2 nodes is option number 1. Okay, so that's how it is correct one. So this was a little tricky, but yeah, you just have to count the number of nodes. What about this question 104 of June 2019? This is highest energy pi molecular orbital of the allylic system. So highest energy pi molecular orbital you have to draw. You know that allylic system will have 3 orbitals, molecular orbitals. This will be like psi1, psi2 and psi3. So highest one is going to be psi3. All right. Now the psi3 will have how many nodes? Nodes should be 2 here. So you just have to look on the options where you have 2 nodes. That is going to be the correct option. So that is how you have to approach it. The correct answer is already marked. You just have to cross check that whether you are getting it or not. Alright, so this is how it is done. It's pretty simple. Let's go for the next one then. Okay guys, let's see this particular question which was asked in CSIR December 2019, and this question was a 4-marker question again. Okay, so this says that the degeneracy of the state having energy 27H square upon 8 ml square. They are asking the degeneracy, so let's try to do it. So you have got 27H square upon 8 ml square. How to do this? You know, since it is a 3D cubic box, so generally the energy is given by nx square plus ny square plus nz square h square upon 8 ml square. This is how we do it. Now you just have to relate, you just have to see that what is the combination of nx square, ny square and nz square that is going to give you 27 as the final value. So you have to just look for the combinations of nx, ny and nz. Basically in the exam I tell you what happened actually. The students got 27. They got very excited and they just did it like 3 square plus 3 square plus 3 square like that. So 3 square is 9 plus 9 plus 9. So 9 plus 9 is 18 plus 9 is 27. So they got 27 and they just said okay fine, we got one combination that is 3, 3 and 3. So the answer should be 1. Most of the people did that, but that's not the correct way of doing. You have to look for whether there are other options or not. So just see, there is one more combination which is possible. If I do this 5 square plus 1 square plus 1 square, make sure this thing that you cannot take any value of n as 0. Okay, you cannot take 0. Minimum value which you can take is 1. So this is also one of the combination, right? 5 square is 25 plus 1 will give you 26 plus 1 will give you 27. So here again you got 27. So the other combination which is possible is 5 1 1. Now you can just rearrange this combination. You can make it as 1 5 1 or you can make it as 1 1 5. So you got how many combinations? Total combinations are 1 2 3 and 4. You got 4 combinations. So correct option is option number 1. So don't get overexcited when you get easy questions. This was very easy, but yet people did silly mistake in this question and they just like went with option number 4, which was not the correct option. Okay, so option number 1 is correct. The correct answer is 4. Alright, so it's as simple as that. Let's go for the next one then. Alright, the next question which was asked in CSIR December 2019, it is basically the easiest question based upon your Eagen value and Eagen function concept. So you know that if you have an operator A, if you operate it on wave function, and if you get some constant along with that, like if you get that wave function back along with some constant, So this particular constant is called as Eagen value, and this psi is called as Eagen function. Okay, this is called as Eagen function. So this you should know. Now based upon that we'll try to see. It says which is not an Eagen function, so you have to keep on operating. This is the operator, you have to operate it on the function and see whether you are getting the function back or not. If you do any of the option, you will get that back. Let's say I am doing the first one. It's like d2 by dx square minus x square. It's the operator, and I'm going to operate it on e to the power minus x square by 2. If I operate it, what I'm going to get is d2 by dx square of e to the power minus x square by 2 and minus x square and e to the power minus x square by 2. Okay, to solve this particular part, I would like to use another slide and I'll show you how this will be done. So we are just going to solve this part. Okay, we will just see this. So that means that you have to differentiate 2 times. So d by dx of e to the power minus x square by 2. When you solve this, d by dx will remain as it is. Differentiation of e to the power x, it just gives you the same thing. Okay, multiplied by whatever the coefficient of x you have. Okay, whatever the coefficient of x you have, you just have to multiply with that. So it is minus 1 by 2, so I'll write down minus 1 by 2. Along with that, you have to multiply, or you have to just differentiate this particular part also, that is x square also. So this x square will get differentiated and you will get 2x, and yeah, that's what you will get. Okay, so x square is going to give you 2x over here. Alright, so now the things are little simple now. You just have to solve this. So you can cancel this 2 and 2. You are going to get differentiation of like you have just got minus x e to the power minus x square by 2. This is what you have got. Okay, again you have to differentiate. In that case, you have to use the product rule. In that, you differentiate. You don't differentiate e to the power minus x by 2 minus x square by 2, but you differentiate minus x and plus, then you don't differentiate minus x and you differentiate e to the power minus x square by 2. So that's what I'm going to do. This particular part is going to remain as it is, x square by 2. Differentiation of this is going to give me minus 1 and this will be minus x, and differentiation of this, we have got this, right? So minus x e to the power minus x square by 2. So if I put the value, so basically I'm going to get minus e to the power, or I'll write down this over here. So I will be getting minus, this minus will become minus, and e to the power minus x square by 2. This minus and this minus will become plus. It will become x square e to the power minus x square by 2. So this is the value of this, what we have got. So let's try to put this value over there to solve it further. So the value of this was how much? Minus e to the power minus x square by 2. So minus e to the power minus x square by 2 and plus x square e to the power and plus x square e to the power minus x square by 2. Or ye wala part will remain as it is. So this will be minus x square e to the power minus x square by 2. Okay, we have just got the value of this much. So you can cancel out these two terms. It is in plus and minus. You just got minus e to the power minus x square by 2. So you started from the wave function. You got your wave function back. What is the Eagen value here? So I'll write down Eagen value is minus 1 in this case. So is the first option a Eagen function? Yes, the first option is the Eagen function. So first is the correct one. Now how the answer is second, I will not calculate, I will just tell you that how we have approached over there. See, in this and this, the only difference is with the sign here. Instead of minus, we have plus. So if we would have plus, we would have got plus here also, we would have got plus here also. So will these two functions got cancelled? No, they would have been plus, and that's why it would have become 2x square e to the power minus x square by 2. So basically what I am trying to say is, in this step, in this particular step, for second one, you would have got plus here. So what you would have got is this, that is minus e to the power minus x square by 2 and plus 2 times, like this will be like x square e to the power minus x square by 2 plus x square e to the power minus x square by 2. You understood why it is? Because of plus sign here in option number 2. I have solved first option 1 here. Okay, for option 2 we have plus sign, so that's why it is. Now minus minus will become plus, it will be minus e to the power minus x square by 2, and this will become 2x square e to the power minus x square by 2. Now can you take this e to the power minus x square by 2 common? So although I can take, but did I got any constant here? So no, I didn't got any constant here. Okay, there is no constant over here, so that's why it's not a Eagen function in this case. Okay, so you can just say that this will be your answer. So in the question they were asking that which is not an Eagen function. So because you didn't got any constant along with the wave function, it's not a constant, it's again a function, right? So you cannot say that it's a Eagen function. Okay, so option number 2 is the one where it is not a Eagen function. You can check out option 3 and 4, you will get Eagen function over there. So second is the one which is not Eagen function. All right, so that's why it is, that's how it will be done. It is a pretty simple question. The calculation is little difficult over here for non-mathematics student, like calculating differential and all, it is little tricky, but yet I would suggest that practice from the basics and you will get to know. Okay, it's pretty simple. Okay, let's go for the next one then. It was asked in CSIR June 2019. It says for a particle of mass m, okay, it should be mass m, in one dimensional box of length 12, the energy level corresponding to n is equals to 8 is how much? Now again it is simple, your energy formula for nth level is n square h square upon 8 ml square. Now this is for a particle in 1D box, okay, for one dimensional box particle. So since n value is given 8, so let's do it. So E8 will be like 8 square h square upon 8m, and the length is given 2l, right? So 2l square, how much it will be? 8 square is 64, h square divided by 8m, and this is going to be 4l square. You can cancel out some of the terms, like 8 times it can be cancelled out, and 4 2 times it can be cancelled out. So in the numerator you are going to get 2h square divided by, it will be ml square. It's as simple as that. Option number 4 is the correct option. See how pretty simple questions are asked from your CSIR NET exam. This was 2 marker. Okay, this was a 2 marker question. All right, let's take the next one then. This question is a very good question. It was asked in CSIR June 2019 exam. It says energy function from the trial wave function is, okay, the trial wave function is, sorry, the energy is given to you. They are asking the variationally optimized energy. Similar kind of questions we have done in my video on the trial, on the variational theorem. Okay, that video link I have already given, so you should watch that video. Okay, we have done some types of questions and this was one of them. Okay, this type of question means we have already discussed, and that video I have uploaded before June exam, so that means those who have watched, they got benefit from that. Okay, so try to watch that video, it will definitely help you in future. So yeah, E alpha, that means energy of the alpha state is given to you, that is alpha square minus 3 alpha by 6. Whenever this kind of question is asked, and whenever it is asked to find out variationally optimized energy, what you have to do is you have to basically find out the minimum or maximum value of energy. So you just have to differentiate this energy, whatever energy value is given, with respect to whatever constant is there. So since alpha is, whatever variable is there, since alpha is the variable here, so I have just differentiated with respect to alpha. So what I'll get is, I'll just take 1 by 6 outside. Now d by d alpha of alpha square minus 3 will be outside, and d by d alpha of alpha. Now you know that x square will give you 2x, in the same way alpha square is going to give you 2 alpha, right? Minus this 3 will remain as it is, and differentiation of x is 1, in the same way differentiation of alpha with respect to alpha will be 1. So you will get this thing, right? So this is what you have got. Now next step is, just take this particular differential is equals to 0. So the step 2, this is step 1, okay, this is step 1. Step 2 is to take this dE by d alpha is equals to 0. So that means 1 by 6 and 2 alpha minus 3, just take it equal to 0. So this 6 will go other side and it will become 0. So 2 alpha minus 3 will be 0, or you can say that alpha is equals to 3 by 2. So you got a value of alpha. Now variationally optimized energy will be that where you can put this value of alpha in the energy term. Okay, so that is going to be your step 3. So step 3rd is to find out energy for this given alpha value. So you have to put 3 by 2 wherever you have alpha in the energy formula. So here you have to put 3 by 2. So 3 by 2 is square minus 3 into 3 by 2 and divided by 6, right? So just solve this. So basically you are going to get this much. 3 by 2 means 9 by 4 minus 9 by 2 divided by 6. So on solving the numerator you will get minus 9 by 4 after taking LCM and all, because this is a bigger number, this is smaller, and divided by 6. So you can write it down as 6 by 1, and the solution I'm just going to do here. So that will be minus 9 upon 4 multiplied by 1 upon 6. Now cancel out by 3. So 3 times and 3 2 times. So the final answer which you are going to get is minus 3 upon 8. This will be your answer, and that's how it will be done. So just by following these 3 steps, you can calculate variationally optimized energy whenever it is asked, wherever it is asked, however it will be asked. Alright, so yeah, that's how it will be done. Let's take the next question then. Alright, let's take this particular question which was asked in CSIR December 2018 exam, and this was again asked for 4 marks. Alright, the question says that for one-dimensional harmonic oscillator perturbed by x cube potential, the sum of first order and second order energy correction to the ground state energy is. Okay, now try to understand this thing, that whenever you have whenever you have to solve these types of question, especially if you have simple harmonic oscillator type of question, so first order energy correction, okay, remember this thing, okay, I'm just giving you one note. So first order energy correction, if you are doing the first order energy correction for perturbed part, okay, for perturbed part having odd power, okay, if the power of the perturbed part is odd, which is here, the power is 3, in that case the first order energy correction, okay, first order energy correction is always 0, okay, correction is always 0, remember this thing. So first order energy correction became 0, and you know that the second order energy correction is always negative, okay, second order energy correction is always negative. Why it is negative? Because if you see the formula for second order energy correction, in the denominator we differentiate, or we take difference from lower energy to the higher energy. So it's like E1 minus E2, E2 minus E3, like that, okay. So we subtract greater energy from the lesser energy value. So that's why denominator becomes negative, and overall second order energy correction becomes negative. So second order energy correction is negative, first order energy correction is 0, sum of a negative number and a 0 is always negative number. So sum of both of them, which was asked in the question, is going to give you a negative term, that is less than 0, okay. So that's how this will be done. Alright, fine, let's take the next one. It was very simple to approach this, okay. Let's take the next one then. The next question says that the Hermitian operator among the following. Now again this question is from the Hermitian operator. I have made a very nice video on Hermitian operator. Everything has been explained over there. If you have not watched that video yet, I'll just give you the link of that in the I button, and it's highly recommended for you to watch that, okay. I have completed this Hermitian operator over there. So a operator is said to be Hermitian if you take dagger of that operator and you get that operator back. That is called as a Hermitian operator. So let's try to check it out. Let's try to say option 1, okay. Let's see the option 1 first of all. So I'm taking option 1, that is I h cross and d2 by dx square, okay. Let it be A, okay. If I take A dagger, so that means I h cross d2 by dx square and whole dagger, okay. That means I will have I h cross star complex conjugate of that and d2 by dx square dagger. Now you know that if you have iota and if you take complex conjugate of that, you get a negative of that, so you get minus I h cross, and if and the dagger of d2 by dx square is d2 by dx square itself, so you'll get d2 by dx square itself. So what you got? Did you got the same operator back? No, you didn't got that. The operator was I h cross d2 by dx square, you got minus I h cross d2 by dx square. So what you can say is, for option number 1, you got A dagger is equals to minus A. So that means this is anti-Hermitian, okay. This is anti-Hermitian. So option 1 is not correct. They were asking that which is Hermitian. Let's see option number 2, okay. So I'm just going to solve option 2. So option 2, if I solve, So I'll again take A is equals to minus IH cross and d by dx. Okay, so A dagger will be how much? That will be minus IH cross and d by dx whole dagger. So this is going to be like minus, I'll take outside IH cross and complex conjugate of that d by dx dagger. So this is going to give me how much? Minus will be written as it is, I is going to become minus I h cross, and you know d by dx dagger is minus d by dx. Okay, this you should know. So that means overall it will be like minus minus plus, and again minus is going to make it minus. So you are going to get minus I h cross d by dx. Did you got it as same? Yes. So what we have just found that after taking A dagger, we have got same as A, right? See, both the things are same. So A dagger is equals to A. So that's why what we can say that A is Hermitian operator. Okay, so it's a Hermitian operator. Option number 2 is the correct option. It's a Hermitian operator. Alright, so this is how it will be done. Alright guys, so that's all for this video. Thank you so much for watching. I hope that whatever we have discussed, whatever the questions we have taken, you guys understood it well. And if you like this video, do give it a like, share it with your friends. If you have not subscribed the channel yet, please do subscribe the channel. And I have a Facebook page and Instagram page as well. So if you are interested, you can join me on those social media platforms as well. The handle is @chemaholic. You can search it on Facebook or you can search it on Instagram, both the places. Okay, the channel name is same, that is all about chemistry. Alright guys, thank you so much for watching this particular video. I'll see you in the next one with a new topic. Till then, have a great day. Bye bye.